In this video, we're going to talk about the empirical rule. The empirical rule works for data sets that have a distribution that is approximately bell-shaped. And what it says is that if we have an approximately bell-shaped distribution, about 68% of the data values fall within one standard deviation of the mean. So between one standard deviation below the mean and one standard deviation above the mean. About 95% of the values fall within two standard deviations of the mean, and about 99.7% of the values fall within three standard deviations of the mean. Here's a picture representation of the empirical rule. So here we have a bell-shaped distribution. In the middle is our mean, the x bar, and if we have 68% of the data values within one standard deviation of the mean, since a bell-shaped distribution is symmetric, that means that actually on each side, so going down one standard deviation from the mean and then going up one standard deviation from the mean, on each side of that we have 34% of the data values. If we go out two standard deviations onto each side, then we get a total of 95% within this range, from two standard deviations below the mean to two standard deviations above the mean. And we can again separate this into little regions with their own percentages. So if this was 34% and this entire region is 95%, then actually the percentages in this region and this region are both 13.5%. If we go out three standard deviations, then we end up with 99.7% of the data. So the percentage in this region right here is 2.4%, and in this region is 2.4%. And then if we're outside of three standard deviations, so if we're more than three standard deviations below the mean, that whole region from here onto the left is about 0.1% of the data, and the same thing on this end. If we go three standard deviations above the mean, from there to the right is about 0.1% of the data values. Here's an example for the empirical rule. So this is looking at IQ scores, which are approximately bell-shaped. The population mean for IQ scores is 100 and the standard deviation is 15. So let's say that we wanted to find the cutoff scores for the middle 68% of the population. So the middle 68% of IQ scores. Well, 68% was what was within one standard deviation of the mean. So we would just have to go one standard deviation below the mean and one standard deviation above the mean, and that would give us our two cutoff scores. If we take our mean and subtract one standard deviation, we get 85. If we add one standard deviation, we get 115. So in other words, about 68% of the population has IQ scores between 85 and 115. The next question was, what percentage of the population would have IQ scores between 100 and 145? So for this, let's go back to our picture of the empirical rule. And what we want to do is locate 100 and 145 in the picture. So to do that, we're first going to put our mean in the middle, which is 100. And then we can start going by standard deviations to get these different cutoffs. So if we go up from our mean by one standard deviation, that's 115. If we go up two standard deviations, that's 130. Three standard deviations would be 145. The two numbers we were interested in were the 100 and the 145. So now we've got those two numbers in our picture. We can add up the percentages in these regions to get our answer. So we take the 34% plus the 13.5% plus the 2.35% and add those together, which would tell us that approximately 49.85% of the population has IQ scores between 100 and 145. Finally, what percentage of the population would have IQ scores below 85? So to do this, again, we're going to put some numbers into our picture. So to locate the 85, we want to start with the mean, which is in the middle, and then we're going down, and if we go down by 1 standard deviation, that gets us to 85. So here's the 85 right here, and we want to know what percentage has IQ scores below that. So we're going to add the percentages in these three regions. So we've got the 13.5%, the 2.35%, and 0.15% over here. If we add those three together, we get 16%. So approximately 16% of the population would have IQ scores below 85. The range rule of thumb is based on the empirical rule that says about 95% of sample values lie within 2 standard deviations of the mean. So usual values are ones that we think are typical and not too extreme. So they'd be ones that were in that middle 95% of the data. So our minimum usual value is the mean minus 2 standard deviations. And our maximum usual value is the mean plus 2 standard deviations. So these are the two cutoffs for where we would consider something to be a usual value. We can also use the range rule of thumb to estimate a value of the standard deviation S. There will be some places later in the course where we need an estimate of the standard deviation and we don't have one that we have actually measured. So what we can do is to take an estimated range and divide that by 4. Because a range is a lot of times easier to estimate just by thinking about data than a standard deviation would be. A lot of times you can think about what maybe a maximum value and a minimum value for a set of data might be. And so if we have an estimate like that, we can divide it by 4 and get a very rough estimate of our standard deviation.